Hey everybody, how you guys doing? Sorry I can't be here today. I'm over in the district, but I'm hoping to drop by sometime today to check up on you guys to make sure that you guys are doing what you guys are supposed to be doing. So as you guys can see, we're doing a YouTube video, and what you guys will be doing throughout the year, if I can, is you guys will be doing these YouTube lessons. So I know for sure that you guys are getting the information that you guys need to be getting from me while I'm gone. So it's like me teaching, but I'm not there. So hopefully you guys enjoy this. Again, I'm gonna try to do this anytime I'm not there. So here we go. So as you guys Oh, when you guys are doing today's lesson, what I expect you guys to do is to be taking notes. So please take notes. In addition, guys, I will be checking to see if you guys actually have been writing notes. So make sure that you guys are writing notes today on your notes. Okay? So regarding your quizzes that you guys took yesterday, I have graded them, but since I'm not there, I can't give them back to you. I haven't put them onto PowerSchool yet, but I'm hoping to put on PowerSchool later on today. So again, I'm hoping to put the grades into PowerSchool today. And in addition to that, I'll try to give you guys the quizzes back tomorrow. It depends if anyone has not taken them yet. All right, guys. Today's lesson is kind of a review of what you guys have seen last year. Today, what you guys will be doing is applying the distributor property. But really, before we get to the distributor property, what I'd like to do is to kind of review several things that you guys should know just about some pre-algebra stuff. So here we go. So the first question I have for you is, what's a term? A term is basically, terms in algebra are the part of an expression that you add together. So if you guys look at this, again, if you guys look at the definition, terms in algebra are the part of an expression that you add together. So if you guys can count how many things you're adding here, that's how many terms we have. So there's 4x plus 5 plus 9x. There are actually 3 terms here. 4x is one, 5 is another, 9x is your last one. You have 3 terms here. So we should know what a term is now. I want you guys to look at the next one. Parts of a term. So in this particular expression, 3x plus 7, there are actually 2 terms. One term is 3x, the other term is 7. Why are there 2 terms? Because how many things are being added together? 2 things. Therefore, there are 2 terms. Again, 3x and 7. At this point, what I'd like to do is talk about the different parts of each term. If you have a term like 3x, it actually has 2 parts. As you guys know, the letter is called the variable. Okay? The letter is called the variable. The number in front of the x, which is being multiplied to the x, is called the coefficient. So I want you guys to make sure you guys copy this into your notes and copy it well. It's spelled C-O-E-F-F-I-C-I-E-N-T. The number in front of a variable is called the coefficient. So 3x is a term. It has 2 parts, the coefficient and the variable. The second term here is the 7. Now, if you guys notice, the 7 doesn't have a variable attached to it. It has a special name. When a number is by itself and not attached to a variable, it is called a constant. C-O-N-S-T-A-N-T, a constant. So look at this again. Notice all the vocabulary words you guys should know, which you guys will definitely use in today's lesson. Okay, so next, let's look at the following. Let's say we have a variable x. We could change this so it has an imaginary coefficient. Whenever you see a variable by itself, it has an imaginary coefficient. Can you guess what the imaginary coefficient of the x would be? If you said 1, you'd be correct. Any variable by itself really has an imaginary coefficient of 1. Okay. The next thing I would like to review with you guys from what you guys have been doing in the past is a thing called like terms. Like terms are the following. 12x of like terms, these are terms with exact same variable and power. Again, like terms are terms with exact same variable and power. So you have 12x, negative 3x, 5x, and 8x. All of these terms are like terms because they have the exact same variable, x, 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 and x. Okay? And exact same power for each one of them. The only thing is different are the coefficients. Now for unlike terms, these are terms with different variables and powers. So you see 12x and negative 3a, these are unlike because they have different variables. Just like 5x squared. A lot of people wonder, why is 5x squared different from 12x? Why are they not like? Well, the reason why they are unlike is because they have different exponents. 12x does not have an exponent. 5x squared does. So the x's are actually different. There's x and there's x squared. They are unlike terms. They have to have the exact same exponent. Lastly is 8. Notice that 8 does not have a variable. It is totally different from 12x, negative 3a, and 5x squared. All of these terms are unlike. Okay. Let's review a lot of the things that you guys should know from what we discussed in our past 2 slides. If you guys can see the expression on the top, it says 5x plus 3 plus 9x plus 7. How many terms are there? The question you should be asking is, how many things am I adding together? So the answer for how many terms there are actually 4 terms. 5x, 3, 9x, and 7. This actually answers the first question, which says A, identify the terms. So here, the terms are 5x, comma, 3, comma, 9x, and 7. So the next question is identify the coefficients. Here is asking you, what are the numbers in front of the variables? So my answer to that would be simply 5 and 9. So the next thing is the constants. What numbers are by themselves without the variables? What numbers are by themselves without the variables? They are 3 and 7. So you might see a problem like this on tonight's homework. I'm hoping you guys are able to answer the questions. All right, next. So you guys should remember how to add like terms. Let's say you have 5n plus 3n. How do you add these together? Well, 5n plus 3n, all you do is just add the coefficients and leave the variables alone. So 5n plus 3n is actually equal to 8n. Okay? So what's the answer of the next one? 7p plus 2p. Again, add the coefficients, leave the variables alone. The answer should then be 9p. Okay,